All right, this is number 3.65. This is the Babe Ruth question. Babe Ruth hit a homer over a 10-meter high right field fence, 80 meters from home plate. So this is 80 meters. The fence is 10 meters high. The ball left home plate 0.9 meters above the ground. So the ball went like that and just cleared it. This is 0.9 meters. It was initially at a 43-degree angle. So there's my V initial. This is 43 degrees. They want to know what was the minimum speed, V minimum, initially, when it left the bat. Okay, so this is probably one of the hardest types of problems you're going to do for projectiles, because you feel like you have too many unknowns. What some kids will do is they'll try and figure out something here, because this is always important, V at the top, and the Y direction is 0. People like to do that. People are going to apply the range equation, V naught squared sine 2 theta over G, which is totally incorrect because that only works when it's a level landing. So there's no easy solution to this. What we do know is delta X is this, and delta Y is this minus 0.9 meters. So 9.1 meters is the displacement in the Y direction. Knowing those two, what I'm going to do, and I'm just going to erase this to give myself more room, I'm going to start with the delta Y equation and the delta X equation. Delta Y, V naught Y T plus 1/2 AY T squared. Delta X, V naught X T plus 1/2 AX T squared, but AX is 0, so that's plus 0. This, we just said, was 9.1 meters, and it's positive because it's going up. If I went back a page, you'd see that. V initial on the Y is V naught. We want the Y component, so it's the sine of 43 degrees, plus 1/2 negative 9.8 T squared. Be careful of this. I was going to write minus 4.9. So many kids on the last the kinematics tests would put 4.9 for the 2A delta X equation. 2 times A is not 4.9. Bunch of people did that. Please don't do that again. Alright, so I can't solve this because I don't know V naught and I don't know T, but I have this equation over here which I know is, how far to go, 80 meters equals V naught cosine of 43 degrees times T. Sorry about my writing there. Now, the logical choice would be to solve this equation for T and substitute it in and solve for V naught. I'm not going to do that because I don't really like squaring cosine, this part here, when I substitute. So I'm going to solve this for V naught and get 80 divided by cosine of 43 times T. And I'm going to substitute that in right there and then solve for T, and then when I get my T, I'll plug it back in over here and get what V naught is. You'll see it's just going to be easier to solve. So 9.1 equals 80, we undo that, cos 43 T times sine of 43. I just saw a mistake I made. I never multiplied by T here. So let me add that T. I missed that. Times T. Plus, well, I guess it's not plus anymore, minus 4.9 T squared. So this equation I can solve. T's cancel here. Cosine of 43 divided, or sine of 43 divided by cos of 43 is tan of 43. So it looks like 9.1 equals 80 tan 43 minus 4.9 T squared. So I can get T pretty quickly. 9.1 minus 80 tan 43 equals negative 65 divided by negative 4.9. Second square root of that gives me t of 3.66 seconds is how long it took the ball to leave the yard. If I take that and plug it in there, 80 divided by cos of 43 divided by 3.66 seconds is 29.887 meters per second, which 30 is probably a good answer. I will check it real quick because I am not unlike you in that I enjoy seeing the green. If this turns purple, I'm going to cry. It was green, so 30 meters per second was correct. Hope you enjoyed.